Hello, I'm Michael Isa, Senior Director of Product Management for Huawei Storage product line. Our customers have repeatedly asked me, how is Huawei all-flash storage different than other products in the same storage class on the market? Well, to answer this question, we need to focus on several key differentiating technologies currently present on Dorado V3 all-flash storage. In this video, I will preview some of the key Huawei design technologies embedded within the Huawei SSD module available on Dorado V3 all-flash storage. Our design approach is simple: design a grounds-up SSD module interface for the future. This allows Huawei to be positioned to produce higher density, lower latency SSD modules in the future, while remaining in complete control of the flash chipset, memory, and controller design of all future SSD modules. The Huawei SSD module design is enterprise class and highly optimized for OceanStor storage operating system. Let's take a look at Dorado V3 all-flash storage and some of the technologies that's in it, exclusively the SSD module. You see the system here available for us, and the SSD module are plugged in the back. If we look at this, we notice that off-the-shelf SSDs has typically a controller, some memory, and SSD embedded chipsets, and usually there's an interface here, and that interface has a bandwidth and a latency. What Huawei did for Dorado V3 is it introduced its own designed Huawei SSDs with a Huawei chipset controller, DRAM, and SSDs embedded in it. But one key criteria that we focused on is right off the bat, we designed a very large or fat bandwidth that talks back to the OS layer with much higher bandwidth and very low latency. This allowed us to design an SSD module for today's 3.2 terabytes, and in the future, higher density storage can be provided at ease without a lot of changes to the OS layer. We are planning to introduce 16 terabytes and 32 terabytes SSD in the future with ease due to this very proprietary design with higher bandwidth and low latency. Let's examine some key design parameters at an SSD module level. First, the data consistency of an SSD is important. The second part is data fidelity of an SSD, or simply known as disk lifespan. And the third, but not least, is data security of an SSD. Let's start with data consistency. When you open up the SSD module for Huawei, you will find the SSD controller chipset that's Huawei designed, the memory, and the flash component chipsets. Huawei design ensures that the data is verified in each segment of the transmission process, starting at a high-speed interface and ending with a flash chipset. Each component serves as a data transmission owner for the respective part of the path. The multi-levels of checks and balances ensures integrity and consistency of data as it's written to the flash or read back from the flash chipset. The multi-step verification process ensures that data consistency for Huawei SSD module design, and we can achieve a user bitrate error as low as 10 to the negative 17, which is 10 times superior than most advanced mechanical hard drives on the market today, and spec much higher than off-the-shelf SSD modules on the market. Second, let's discuss Huawei's SSD module service life. If an error occurs when a data signal is being read from the flash chipset, the original data would be wrongly decoded. We may start to question whether the SSD module is nearing the end of its lifespan. In fact, the probability of these errors occurring in real life defines the disk life. For example, if we consider off-the-shelf SSD module, it uses the traditional decoding method. It may incorrectly decode a bit as a 1 while the accurate data should be 0. Why, you ask? Well, the reason is usually contributed to the slight variation in the signal, where somehow one may think that the SSD module itself may have reached prematurely the end of its service life. Huawei SSD Module Design addresses this issue by introducing a new firmware code within the SSD module called Low Density Parity Check, also known as LDPC. It is responsible to linearly correct errors in the decoding process. To explain this simply, each bit has a likelihood rate of probability. If the likelihood rate of one bit in a byte is low, whereas the other 3 bits is high, LDPC code detects this and can restore the bit to the correct value automatically. In comparison, Huawei LDPC technology embedded within the SSD module's firmware can highly increase the lifespan of the SSD by 4 times, while significantly reducing the SSD module failure service time. Last but not least, let's discuss data security, as it is the utmost importance to some of our customers. Huawei design approach is to provide redundancy protections to improve reliability across the entire SSD from 2 aspects. First is the flash chipset itself. Occasional damage to the flash chipset does not affect data recovery efforts. Hardware and software recovery mechanisms are available to fully restore customer data in most instances, enhancing data reliability metrics. Second, Huawei adopts patented packet technology protections applied at a capacitor level, which is embedded inside the SSD module. An occasional capacitor short circuit or failure does not affect SSD reliability. These are some of the several design approaches available to you on Dorado V3 all-flash storage, which provide our customers with assurance that their data will remain consistent, reliable, and secure across the entire solution.